Hello, my favorite freshman class. We are going to start section 3 right now. It's all formula writing, okay? What we're going to start with are binary ionic compounds. Now, don't forget, binary means two elements only, just like it says right there. Oh, also a reminder, make sure you have your periodic chart out in front of you at all times during this video. Now, an ionic compound, which you've already gone over, is a metal plus a nonmetal. Metal to the left of the stair step, nonmetal to the right of the stair step. When writing these binary ionic compounds, we're going to be using those oxidation numbers literally right from your periodic chart. Now, that oxidation number that we're looking at right there is the same as your atomic number on your periodic chart. So take a look. When you see that atomic charge, and if an element has more than one atomic charge, which many of your nonmetals do and your transition metals do, you're going to go with the top atomic charge. But from here on out, you'll be listening to me refer to it as an oxidation number, okay? So oxidation number, atomic charge. That is what we're dealing with here. When we're writing these, the metal is always written first. Sometimes known as your cation. They typically have that positive charge. Remember, those metals, the metals tend to lose those electrons, leaving a positive charge behind. The nonmetal is written second, also known as an anion. So let me go ahead and write that in there so you can add that to your notes. Cation written first, and then we have an anion written first. Excuse me a second. Okay, so we've got our metal, cation, our nonmetal anion written second. All of these compounds are going to end with an IDE. Oopsie, sorry, here we go again. You know me and my pen. Always having problems with that. Okay, IDE. For example, if you had, I'm just going to write it right up here, oxygen. And say that was that is a nonmetal, and that was the second element of this binary compound, you would say oxide. Give you another example. Phosphorus. Again, another nonmetal. All compounds, again, end in IDE. How would I say that? I would just change this to IDE, and I would say phosphide. One more example, kind of just scribbling all over this board here. Nitrogen, again, has to end in IDE in a binary compound, and I would say nitride. One more, I'll come over here. Sulfur, you would say sulfide. I hope that makes sense. Get the hang of it there. But again, they all end in IDE. Let's start with some practice ones. Again, make sure you have your periodic chart out in front of you. You need to have this in order to accomplish this correctly. So we have sodium plus oxygen. If you take a look at sodium and you look at that atomic charge, which I'm going to start referring to as the oxidation state, it has an oxidation state. Let me get my pen going here again. Sorry. 1. Oxygen has an oxidation state of 2. When we're writing these binary ionic compounds, these oxidation states switch. So when I write this, it is going to be Na2O. Yes, there's 1, and that would switch, but when writing these, we never write 1. When you do not have a subscript there, we assume that that element is 1 in the chemistry world of things. So I'm going to erase that and keep it just like that, Na2O. How would I say that now? Okay, remember they all end in IDE. So I would say sodium oxide, just like I showed you before. Let's try another one. Magnesium plus chlorine. Now, magnesium, if you look at your periodic chart, has an oxidation state. I'm going to show a little 2 here. That's just a little reminder. I think it helps you and alleviates mistakes later on. Whoa, sorry. Skipping ahead, my elbow just hit that. I apologize. So magnesium, it has an oxidation state of 2, and chlorine has an oxidation state of 1. So I'm going to write a little 2 there and a little 1 here. Again, that's just a helpful reminder of what their atomic charge oxidation state is and that they switch. Again, I do think this helps alleviate mistakes. The 1 is now going to come over here by the magnesium, and the 2 is now going to come over here by the chlorine. In order to write that, it would look like this, MgCl2. The name, so this is a formula, and here is the name. In order to say that, I would say magnesium, correct, chloride. Those of you that are guessing on your own. Very good. Let's try another. We have barium boron plus oxygen. Now boron has an oxidation state, I have to do this each and every time, 3. And oxygen has an oxidation state of 2. Again, those oxidation states are going to switch. So now I will write it B2O3. How would I say that? Boron oxide. Easy enough. Let's try another. And I'm actually going to put all of these up here, and then I won't have to keep switching my pen each and every time. Okay, get my pen going again. We have aluminum plus oxygen. Take a peek at your periodic chart. Aluminum does have an oxidation state of 3. Oxygen has an oxidation state of 2. These guys are going to switch. I shall write it Al2O3. What is the name of this formula? I would call it aluminum oxide. Very good. Another one, aluminum plus chlorine. Aluminum, again, has an oxidation state of 3. And chlorine, look at that top one. That's why I'm getting that 1, okay? You can see that it has actually 4 oxidation states there. A 1, a 3, a 5, and a 7. I am going to go with the top oxidation state of 1. These guys switch. And I now have AlCl3. Aluminum. Are you already saying it? Chloride. Good, good, good. Let's try the next one. We have cesium plus sulfur. Cesium has an oxidation state of 1. Sulfur has an oxidation state of 2. Again, these oxidation states are going to switch, so I will write it CS2S. How do I say that? What is the name? It's cesium sulfide. Note they are all ending in IDE. Barium plus nitrogen. Barium, look closely, has an oxidation state of 2. Nitrogen does have more than one oxidation state there, or atomic charge. Please go with the top atomic charge, also known as the oxidation state, which is 3. And I'm going to write that Ba3N2. And I will call that barium. Do you have it already? I hope so. Nitride. The next one, aluminum. Probably had that memorized by now. Has an oxidation state of 3. And sulfur has an oxidation state of 2. Yes, they switch. Easy enough. Al2S3. What do I call that? Don't forget it ends in IDE. Aluminum sulfide. Very good. 2 more to go. Here we have radon plus phosphorus. Radon has, oh sorry, guess what? Hit that again, my elbow. Why is my elbow there? I do not know. I apologize. Okay, aluminum, oxidation state of 3. We already did that one, didn't we? Yes, we did. So radon has an oxidation state of 2. Phosphorus has an oxidation state of 3. Yes, they switch. Ra3, P2. Easy enough. Radon, phosphide. Very good. Last one, calcium. Oxidation state of 2. Nitrogen, oxidation state of 3. Yes, they switch. Ca3 and 2. And I bet you already have this written ahead of me. I'm hoping. Calcium nitride. There you have it. That's how we're going to continue to write binary ionic compounds. Working with only 2 elements here, we have a metal plus a nonmetal. They do all end in IDE, and remember we go with that top oxidation state. Okay, now I'm going to introduce you to transition binary. What do you think the transition are? Well, yes, that would be your transition metals, okay? Binary, again, meaning working with 2 elements, okay? Now, these guys are a little tricky because they do have more than one oxidation state. When you have more than one oxidation state, you need to tell me which one you're using. Yes, I know, I just said we'll go with the top oxidation state, but let's leave that rule only and solely to the non-metals. So on the non-metal side, we are from here on out going to only work with the top oxidation state, my favorite freshman, okay? So in the transition metals, it's kind of like a recipe. I don't know, did you use 1 egg? Did you use 2 eggs? You need to tell me. So it's a recipe. So if I were to give you some elements put together, I need to know which oxidation state, which atomic charge you're using. And in order to tell me that, what we're going to be using here are Roman numerals to indicate which one to use. Okay? So if you look at iron Roman numeral 2 plus sulfur, let's take a peek at iron. When you look at iron, you can see that it has an atomic charge of 2 and has an atomic charge of 3. So you need to tell me which one you're using. And how you tell me is by Roman numerals. We probably should go over Roman numerals really quick. I know some of you, this is new to you, Roman numerals. 1, 2, 3, 4, 5, 6, 7, 8. And I will stop right there. 2, 3, 4, 5, 6, 7, and 8. I think that will work very well for us right now. So you definitely need to know these. You need to know your Roman numerals. So if it's a matter of making flashcards, please do so. You have to have those memorized. I will not be giving those to you. So let's take a look at iron. Again, it has an oxidation state of 2 and an oxidation state of 3. So when I put these two together, that 2 is telling me the oxidation state of iron that I'm currently using. Right here. So I'm going to put a little 2 here just like I did before. I do think that helps alleviate mistakes. Let's take a look at sulfur. Again, that's a nonmetal. Yes, it has more than one oxidation state there, but what are we going to use? The top atomic charge, that top oxidation state, okay, which is 2. So now, just like we did before, we're going to switch those oxidation states. Oh my, they're the same, aren't they? So what happens in this case, they cancel each other out. So that would be the same as writing FeS. What is the name of this guy? Iron sulfide, still ending in IDE, okay? I'm going to put these up here so I don't have to keep changing my pen, which I know is annoying, I'm sure. Let me get my pen going again. Every time I switch something on the PowerPoint, I have to get my pen going again. Okay, so let's try another one. Here's iron. Again, remember, the choices were 2 or 3. So you're using 1 egg, 2 eggs, 3 eggs, you have to tell me. So how you tell me, again, is by this Roman numeral, on the metals. These are transition metals. Many of them have more than one oxidation state, so this is how you tell me. So again, I'm going to put, I have a feeling my pen wasn't working there. I'm going to put a little 3 here, that's telling me the oxidation state of that. Oxygen has an oxidation state of 2. Yes, they switch, no different than what we've been doing. 2 goes there, the 3 goes after the oxygen.